Hey guys, we're going to do a quick little video here on looking at factoring a difference of squares. During our Zoom meeting today, we talked about this. So we're going to do a quick recap of that for those who couldn't make the Zoom meeting, and we will show you that. I do have an assistant here. Oh, oh there you go. Say hi.
Hi.
What's your name?
Leah.
Yeah. You doing some math today?
Yes.
Yes. Okay. So I'll ask you questions. Okay. Okay. So we're going to share our screen here with my OneNote, and we'll share that. There we go. Okay. So you can see on here, hopefully the work we're about to do here. So I'm going to take a look at drawing some stuff. Okay. So let's take a look at the pattern A plus B, and we're going to multiply that by A minus B. So if I use that technique we talked about called FOIL, the first would be a squared, a times a times negative b would be negative ab if I keep it alphabetical, and b times a would be a b. And if I do b times negative b, I get negative b squared. And if I group that, I'm going to have a squared. And notice that these two middle terms will cancel out for us. They're going to go to 0, and I'm just left with my negative b squared on the end. So I'm going to do that with numbers now, an actual maybe binomial you're probably more familiar to seeing. X plus 2 times x minus 2. And notice that each bracket is really the same thing, except one is a plus sign, one is a minus sign. And they're called conjugates. So one's minus. So if I use FOIL on that, I get x times x, which is x squared. Oh boy, x squared. And then x times negative 2 is negative 2x. 2 times x is 2x. And 2 times negative 2 is negative 4. So I get x squared minus 4. Once again, notice that these two terms would cancel out, negative 2x plus 2x. So this I should refer to as a difference of squares pattern. So difference in math, meaning subtraction. So we have to have subtraction. So there's subtraction there, and there's subtraction there. And then it's called difference of squares. Hello. And I'm going to actually get rid of that. It's kind of bugging me. Can I get rid of that? Oh, here we go. I know, get rid of that. Stop video. There we go. So difference of squares. So difference meaning subtraction, squares meaning a perfect square. So 4 is a perfect square. Square root of 4 is 2. So if we are looking at a pattern that's x squared minus, say, 4, we know we can do the opposite of expanding, which is what this was. So we expanded it to that. So if we were to factor it, we would be going the other way. We would be going back to that. So since this is a difference, and that are perfect squares, we can factor this into two binomials, x plus 2, x minus 2. So why don't you try the next one here? Let's make this x squared minus 25. Okay, so is this a difference of squares? Well, we definitely have a difference, and we know 25 is a perfect square. Square root of 25 is 5. And we know x squared is a perfect square. Square root of x squared is x. So we should be able to factor this into our two conjugates. So plus and minus. Square root of x squared is x, and then 5 and 5. And once again, if you expand that, you should be able to get back to the starting point, the question that you were given in the beginning. So can we get back to this by using our FOIL? And we'll show that you definitely can. X times x is x squared. X times negative 5 is negative 5x. 5 times x is 5x. And 5 times negative 5 is negative 25. So we can see the middle terms cancel out again. So we get x squared minus 25, which is what we started with. Now, the actual answer is this, though. That's the answer to the question if we were to ask to factor it. I'm just showing you that expansion is the opposite of factoring and gets you back to your beginning so you can check your work. Okay, so let's take a look at maybe a little harder one. Let's say you had x squared minus 81, or x squared plus, let's say, 49. Okay, so if you've given those a try, you can see that 81 and x squared are perfect squares, and we're subtracting, so we have a difference of squares. So that would be x, that would be x. And then you can put the plus and minus however you want. You can do plus and minus or minus and plus, but the goal is, or the key is, they have to be opposite to each other. And then the square root of 81 is 9. So minus 9 here and plus 9 here. Now, 49 is a perfect square. Square root of 49 is 7, and x is a perfect square, which square root of x squared is x. And so let's just say you thought, well, I'm going to throw this in here. So I'm going to get x plus 7, x minus 7. You may think, well, look, there I did it. I square rooted 49, I square rooted x squared. I got these two beautiful conjugates. But please remember that it has to be a difference of squares, a difference meaning subtraction. So this, no matter how much you might want it to be, is not a subtraction sign. So let's expand the 2 out and see if this makes sense. So x squared plus 9x, if I use FOIL, minus 9x minus 81. So x squared minus 81. Once again, notice that those two middle terms are going to cancel. Okay. If I expand this out, I get x squared, x times negative 7 would be negative 7x and 7x. So it looks like they're going to cancel. And then I get x squared, sorry, x times negative, sorry, 7 times negative 7, the negative 49. And so that gives me x squared minus 49. Now notice that is not what you started with. That is a difference thing there. So, so this, I guess we would call this wrong. I guess that would be wrong. So wrong, it's not right. And the big thing here is this actually would be called a sum of squares, not some squares, but sum of squares. And there actually is no factoring. It doesn't matter how good you are at math, there's no factoring for that. So really it can't be factored. There's no factoring for sum of squares, just for difference of squares. Okay, so I'm going to take a look at the sheet I'm going to give you for practice here. I'm just going to show you 2 questions that, or let's write 3 down. Let's just 3 and think of which ones could you factor. Let's say it said factor, okay? And so let's take a look at x squared minus, let's say 16x, and let's try x squared plus 25, and then x squared minus let's say 40, actually let's do 121. Okay, so we do have some factoring. Now, we notice about the first one is that both terms contain an x. So let's look for GCF first. I think it's always a good rule of thumb, greatest common factor. So I can definitely factor out an x, and that would leave me with an x and a minus 16. Oh, I'm sorry, that would leave me with, I think I said it right, just didn't write it right. So that would leave me with an x and a minus 16. Now this is not a difference of squares here. Although they both look like perfect squares, this x makes, the x on the 16 part, that makes that not a perfect square. So you actually can't use difference of squares for that question, okay? The second choice, we do have a perfect square here. We do have a perfect square here. The problem is we don't have a subtraction sign. So this is not a difference of squares, not DOS. And so you cannot factor this. So that's as simple as it goes. So basic instruction on x here, meaning you cannot factor that. Next term, we have x squared, which is a perfect square. We have 121, which is a perfect square. And we do have the difference. So we can factor this. So we get 2 brackets, x and x, and now 11 and 11, because the square root of 121 is 11. And you make one of them negative and one of them positive, and then you get your conjugates, and you are done. Okay, now I'm gonna do one with a fraction, just I think that'd be a nice way to finish it off. Everyone loves fractions. Fractions are friendly and funny and fantastic. So let's say you have 4x squared and you were minusing, let's say, 16 over 9. Okay. All right. Well, do we have a difference of squares here? Well, we've got a perfect square in front. I know I can square root that quite nicely. Square root of 4 is 2. Square root of x squared is x. Now I got a fraction over here, but 16 is a perfect square. So I know square root of 16 is 4. And I know square root of 9 is 3. And I do have a subtraction sign. So I actually do have a difference of squares. DOS. DOS. Okay, so let's do our brackets. So cool little brackets here. And we're going to make a plus sign and a minus sign. And then we're going to square root both these numbers. So square root of 4x squared is 2x. So I write 2x in each one of those. And the square root of 16 over 9, well, the square root of 16, if I square root 16, I get 4. And the square root of 9 is 3. So this would be 4 over 3. And this would be 4 over 3. So there's our difference of squares here. So sometimes you have to look at it and see, sort of in the first case here, you can see, I'm just going to use some highlighter here. Ooh, that's not a highlighter. There we go. That question there. You had to kind of see whether or not you could do something first, which is just GCF, just factoring the GCF out. This question, because of that plus sign, you cannot factor that. That is a sum of squares, which is non-factorable. And our other example here is a difference of squares. And you can factor that just using the difference of squares approach. And our last one's a little scarier looking at some fractions here, but you can also factor that because that is also a difference of squares here. Okay, so I'm just going to unshare the screen here and just wrap this up. Actually, before I do that, I should write down the homework here. So the homework on this is on sheet. There she is. Let's see here. I'm going to pull this up. What grade are you in, Leah?
2.
Grade 2. What math are you working on today? Do you remember?
No.
Nope. I'm a good teacher. So we were working on, I'm just looking for something here for the kids, adding 2-digit numbers and 3-digit numbers. Is that right?
Yeah.
Sort of? Yeah. Okay, so I'm drawing, here we go. Lessons and sheets. So this should be sheet number 5. Sorry, I'll copy this today. And try numbers 1 to 20. And try the odd ones if you can. That would be great. Okay, so I'm going to stop sharing and stop the video here. And we will see you. Wave, you want to wave my students? There you go. We'll see you guys soon.